Okay, let's go ahead and take a look at this. We're going to look at solving quadratic equations. Let's first of all go ahead and look at if we are multiplying two numbers together to get 12, what are some of our different options? Well, you could take a 3 times a 4, or it could be flipped around to 4 times a 3, because you can multiply in any order you want. Or you could have a 1 times a 12, you could have a 2 times a 6, you could have a 4 times a 3, you could have a half times 24, or you could have a third times 36, or you could have the negative versions of all these, and there are many more. It really goes on forever. So when you're taking two numbers to multiply together to give you something other than 0, there's really infinitely many different possibilities. However, if you are dealing with two numbers multiplied together to give you 0, it's going to either be 0 times anything or anything times 0. So when you have two numbers multiplied together to give you 0, it's really helpful because you really then only have two possibilities. Either the first number is 0, which is p, or in this case the second number is 0, which is q, and that's what we're saying here. Also, in solving quadratics, any quadratic can be written in this form here. Solving quadratics can always be solved by the quadratic formula in completing the square. If a quadratic has no middle term, then you can go ahead and get the squared by itself and then take your root. Some quadratics can be factored. Those are the main ways of solving quadratics. So let's go ahead and solve this by factoring. And whenever you're trying to solve by factoring, you always want to have it set equal to 0. So the first thing we're going to do is get our 77 over to the other side. Now, we don't have it factored yet. We're going to have to get rid of our parentheses before we can attempt to factor. So let's distribute this through. We would get this. Now all we're going to do is factor the left-hand side. We reviewed factoring in previous lessons, so we're not going to go ahead and spend the time doing that in this one. So you now have two things multiplied together to give you 0. Once again, what we said before, when you have two things multiplied together to give you 0, either the first thing has to be 0, or the second thing has to be 0. And then all you have to do is just solve each one of these. And you get x to be negative 7, or when you add 11, divide by 3, you get the second answer to be 11/3. Here we want to also solve this one by factoring, but this one is a rational equation. Once again, we looked at solving rational equations prior to this, so you want to go ahead and find your LCD. So you want to have each denominator factored. The only denominator that factors is the second one, and it factors into your x and your x minus 2. Your LCD is all the different things that occur in the bottom, and we get this. Once again, in solving rational equations, you multiply each fraction by your LCD. First fraction times your LCD, second fraction times your LCD, third fraction times your LCD, and the other side also times your LCD. You'll notice on the first set right here, your x minus 2's are the same and drop out on the top and the bottom. In the second set, your x's are the same and drop out, so you're left with a 3 and an x minus 2. Here, nothing drops out, so you're left with your 2x times your x minus 2. Over here on this side, your x times x minus 2 drops out, and so you're left with just that negative 6. Now we're going to go ahead and eliminate the parentheses. When we do that, you'll notice we have x squareds, which means it's quadratic. And to solve quadratics by factoring or the quadratic formula, you always want to have it set equal to 0. So you bring everything over to one side, collect all your like terms. Now we want to go ahead and factor this. Remember, your first step in factoring is always to look for a greatest common factor. In this case, we can pull an x out of each one. Then you'd be left with a 7x and a minus 1. You now have, once again, two things multiplied together to give you 0. So either the first thing, which is our x, has to be 0, or the second thing has to be 0. Now, when you solve the first one, we get x to be 0. Solving the second one, you'd have to add 1, divide by 7. So then we end up getting these right here for our answers. However, our 0 does not work, because once again, in solving rational equations, you need to make sure when you take the two answers you get that they both work in the original problem. When you take your 0 and plug it in here, it causes you to divide by 0, and remember, you can never divide by 0. When you try plugging in your other answer up here, it never causes any of your denominators to be 0, so that works. So your only answer is the 1/7. So let's go ahead and solve these. Notice there is no x to the first. So really all we have to do is try to get the squared term by itself. So we're going to get rid of the 16 divided by 16. Now we got to get rid of our squaring, so we'll take the square root. Remember when you take the square root to apply the plus or minus. Square root of your fraction, then you can go plus or minus, take the square root of the top, which you should know is 7, square root of the bottom, which you should know is 4. We're going to use the same approach over here on the other one. We're going to go ahead and try to get our squared term right here by itself. So that means we'd have to get rid of the 9. So we're going to divide both sides by the 9 to get rid of the timesing by 9. Now we are going to do just what we did over here, get rid of our squaring. So we're going to take the square root. Remember your plus or minus, square root of your fraction. So now you can take the square root of the top, which is root 7. Square root of the bottom, square root of 9 is just 3. Now we need to finish getting x by itself, so we'd have to add 1 to get x to the other side, to get it, or get 1 to the other side to get it away from the x. So we get 1 plus or minus root 7 over 3. This leads us into what we call completing the square. These are the steps you want to follow for completing the square. You want to get the number in front of your squared term to be a 1. You want to get the variables on one side by themselves by taking the term that has no variables, called your constant, to the other side. Then you want to add half of b squared to both sides, where b is the number in front of your variable to the first power. You then want to factor and then use the square root idea that we were just dealing with. Well, here our number in front of our squared term is already 1. So we're going to get our variables to the on one side by themselves, so we're going to subtract 11. For this particular problem, your b is the negative 8, because it's always what's in front of your term to the first power. You take half of that, which is 4, and square it. You might be wondering, well, isn't it negative 4? Technically, yes, but a negative 4 squared is the same thing as a positive 4 squared. If I add a 4 squared to the left side, I'd also have to add it to the right side. Because remember, what you do to one side, you got to do to the other side. Well, on the right side, that just simplifies down to 5. On the left side, when you factor this, it really factors into two identical parentheses of an x minus 4 times an x minus 4, which you could write then as an x minus 4 squared. When you're completing the square, it's always going to factor into one parenthesis, always squared. You can do this step here, but you can skip it. For the most part, you ask yourself, what's being squared in the beginning? It's an x, so you put an x in the beginning. You ask yourself, what's being squared at the end that you added in? And it's really a 4 being squared, so you put a 4 at the end. The sign that you put here is always the first sign you come across in your problem. Well, now you'd want to go ahead and try to solve it. So you're going to take your square root of both sides. Then you're going to have to go ahead and get x by itself by adding your 4. So you get 4 plus or minus the square root of 5.